work on this question 14. And so this one says sine A equals 4 over 5 with A in quadrant 2. Find cosine A over 2, and I'm gonna choose that. I'm alright using that identity, so the square root of, there, a little thinner, square root 1 plus cosine A divided by 2, and there we go, and then a plus minus in the front. Now I cannot plug this in straight away, the sine A equals 4 over 5, because it says cosine A in here, so I have to do something. Well, this one here is going to give me a clue. The A in quadrant 2, as well as the nice integers 4 and 5, is also going to give me a clue. I have to go back to a previous problem in perhaps another chapter that I remember. So here's my coordinate system, and then I'm going to put in here, let's see, I probably changed the color on this one. There we go. Okay, here would be my angle A right there, because it says in quadrant 2, so that's my angle A. I'm going to go back here, and there we go, and there we go. And now 4 over 5 means that this one here is 4, this one here is 5. This is how the sine is defined. And then I look at this triangle and I say, hey, that's a Pythagorean, of course, because it's a right triangle, and if this is 5, this is 4, and this here must be 3, because 3 squared plus 4 squared equals 5 squared. That's what I said about these here. These integers kind of give me a clue that this one here is going to be a 3, and from that one I readily know what the cosine of A is. Cosine A equals 3 over 5 adjacent over hypotenuse, and I'm in quadrant 2, so I have to put a negative in front of that. Okay, so equals plus minus square root of the fraction bar. I think there's going to be a green fraction bar now, but that won't matter. And then I'm going to have 1 minus 3 over 5 divided by 2 square root. Okay, as you see, let me go back here for a moment. As you see here, I have to know this is how I attack the problem, and so I kind of have to keep things like that in the back of my mind, what I learned previously. Otherwise, so anyway, do this one here. 1 minus 3/5 is, let's see, 1 minus 3/5 over 2 is 2/5 divided by 2, which is 1/5. So I'm going to have plus minus the square root of 1 over 5. And then I have to decide between the plus minus. So again, it's square root of 1 or plus 5. And this is where this A over 2 comes in. If A itself is in quadrant 2, so A is in quadrant 2, then I take half of that A, and I'm going to be in quadrant 1. For A, I'm going to be between 90 degrees and 100 degrees, which means that for A over 2 I'm going to be between 45 and 90 degrees in quadrant 1, and in quadrant 1 the cosine is positive. And again, that's something that I have to know, that the cosine is positive in quadrant 1 and negative in quadrant 2. I'm going to look at the possible answers, and there it is, 1 over the square root of 5. I'm not going to do 15 and 16 because that's what I showed earlier for problem 3. And so what's happening here is that this used to be a multiple choice question, still is, with me giving away that the answer is the first one. And then you would still have to show that by typing, for example, taking the left hand side and getting rid graph that b over 2 with the half angle identities, cotangent b over 2, you would use one of these formulas, the reciprocal of one of these here, and look closely which one you would choose, and then manipulating the right hand side and see that the left hand side equals the right hand side. And that's basically what a lot in chapter 5 is about. Same thing on number 16. Again, I give the answer away, and then you still have to show that. Okay, number 17, graph the following function from 0 to 4 pi, y equals -2 sine squared x over 2. So I'm going to use the graphing calculator and type that in there. -2 sine, I'm going to put parentheses around that, sine x over 2, sine x over 2, parentheses, and this is where I put the square. That's how the calculator accepts it. Then I'm going to go to mode, see that I'm in radians, and go to window, 0 to 4 pi it says. Okay, and then it looks like my amplitude is going to be 2. So I'm going to go from, and actually my amplitude is 2, but it tells me these here that I have to go from -4 to 4, so that's what I'm going to do. So, and what I mean by that is that way it's going to look nicer when I graph it. Then it looks kind of similar to what it looks on the test here. That's what I mean. Okay, and I forgot that this here is the scale, which really doesn't matter a whole lot. I can put a 1 there or pi over 2 or something like that. Doesn't really matter a whole lot. Okay, so there it is. Okay, actually kind of looks like the first one. This one goes down to -2. Yep. Well, let's see, hold on. Yeah, pretty much looks like that. So it's likely going to be the first one. Let me double check the others. Well, definitely not, definitely not, definitely not, definitely not. And I'm just going to double check that I actually have plugged in the right equation. Yep, that's what it is. So it is the first one. Okay, number 18. Okay, evaluate this expression without using a calculator. See on the variable represents positive number. Tangent of the cosine of 2x, and they do that in section 5.5. So I'm basically going to do what they show us there. So this is question 18, and I'm supposed to figure out what this is. Again, I'm going to make myself a coordinate system, because that's what they do in section 5.5. And then I'm going to find another color. There, and there. Shift this maybe a little bit if I'm able to. There we go. Okay. Then this one here is the angle theta. Notice that there is no theta in this equation. However, usually I would take tangent of an angle theta. Well, that theta here is that cosine, the inverse cosine of 2x. And so that's how I define that angle. So that means then, I'm going to pull this over here. At least I try to pull it over there. Get rid of this here for just a moment. Yeah. I don't have enough space. So this one here is the theta equals the inverse cosine of 2x. That's what I wanted to say. Okay, that also means that the cosine of theta equals 2x, and it's the same as saying 2x over 1.